Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR, Enterprise Core exam. This course will cover all topics you need to know to pass the ENCOR exam. In this video, we'll continue our study of spanning tree protocol by looking at STP Tuning, which is the process of adjusting parameters like the bridge priority, port cost, and port priority to modify or tune the STP topology. Here's what we'll cover in this video. We'll look at how to tune the STP topology by modifying the following parameters: bridge priority, port cost, and port priority. Note that STP tuning can also refer to modifying STP timers to optimize STP's performance, but we will not address timers in this video. We covered STP timers in a previous video. And make sure to watch until the end of the quiz for a bonus practice question from Boson Software's ExSim for ENCOR, the best practice exams for ENCOR. Let's get started. Here is the basic topology we'll use for this video. This time there are two VLANs in use, VLAN 10 and VLAN 20. We'll make switch 1 the root bridge for VLAN 10 and the secondary route for VLAN 20, and vice versa for switch 2. We'll make it the root bridge for VLAN 20 and the secondary route for VLAN 10. After that, we'll modify some STP parameters to further control the STP topology. For review, here's the STP algorithm, consisting of root bridge election, root port selection, and designated port selection. You can tune the STP topology in a few ways. One is by modifying the bridge priority of switches, which affects their bridge ID. This plays a role in all three steps of the algorithm. Another is by modifying the cost of ports, which plays a role in root and designated port selection. And the third method is by modifying the priority of ports, which affects their port ID. This also plays a role in root and designated port selection. We'll look at a couple examples of each of these STP tuning methods in this video. Before doing any STP tuning, here is the initial topology for VLAN 10. Due to having the lowest MAC address, switch 3 is the root bridge. And the same goes for VLAN 20, which we're looking at now. Feel free to pause the video if you want to examine the topology, but now we'll get right into tuning it, starting with controlling which switch becomes the root bridge in each VLAN. The only factor that determines which switch becomes the root bridge is the bridge ID, so to control which switch becomes the root bridge, we must modify it. The bridge ID is 64 bits in length, consisting of a 16-bit bridge priority and a 48-bit MAC address. And we can break down the bridge priority into two sections, a 4-bit priority value and a 12-bit extended system ID, which is equivalent to the VLAN ID of the STP instance on Cisco switches running PVST+. As mentioned before, the bridge ID affects root bridge election, root port selection, and designated port selection. However, the MAC address used in the bridge ID is fixed, so only the 16-bit bridge priority can be modified. Furthermore, only the 4 most significant bits of the bridge priority can be modified, because the remaining 12 are reserved for the VLAN ID. Therefore, the minimum increment in which you can configure the bridge priority is 4096. That's the value of the least significant bit that you can configure. If you try to configure a bridge priority that is not an increment of 4096, Cisco iOS will display this error message with a list of allowed values. There are two ways to modify the bridge priority. The first is the spanning tree VLAN root command, which has primary and secondary options. The second is to explicitly specify the priority with the spanning tree VLAN priority command. So, which method should you use? Well, the root primary and secondary commands are not recommended, and here's why. Primary doesn't guarantee that the switch will have the lowest bridge priority, meaning it will not necessarily become the root bridge. Likewise, secondary doesn't guarantee that the switch will have the second lowest bridge priority. To see why that is, let's look at how these two commands work. The primary option sets the priority to 24576, or 4096 lower than the current root bridge, if setting the priority to 24576 wouldn't make this switch the root. However, as we'll see soon, there are some cases where the command won't work. The secondary option is simpler. It sets the priority to 28672, regardless of the priority values of other switches in the LAN. Here's an example of the root primary command on switch 1. Notice that after issuing the command, the priority 24576 command appears in switch 1's running config. And here's the root secondary command. Likewise, after issuing this command, the priority 28672 command appears in switch 2's running config. Both commands are converted to the priority command in the config. And note that the root primary command won't update automatically if another switch is configured with a lower priority. For example, switch 1's priority will remain at 24576, even if I configure another switch with a lower priority. So if all other switches have the default priority value of 32768, these commands work fine. The switch you configured with root primary will have the lowest priority, and the switch you configured with root secondary will have the second lowest. However, if other switches don't have the default priority values, it's possible that these commands won't serve their intended purposes. So it's recommended that you explicitly configure the switch's priority values instead of using these two commands. Here's another limitation of the root primary command. It will not set the bridge priority to 0. Let's test that out. I configured switch 2's priority as 8192. I then issued the spanning tree VLAN 10 root primary command on switch 1, and its priority became 4096. So in this case, the command worked as intended. What if I set switch 2's priority to 4096? Switch 2 has a lower MAC address than switch 1, so with the same priority, switch 2 is the root bridge, not switch 1. To make switch 1 the root bridge again, I once again issued the root primary command, but it displays an error message. Failed to make the bridge root for VLAN 10. It may be possible to make the bridge root by setting the priority for some or all of these instances to 0. So the command didn't work. It isn't able to set switch 1's bridge priority to 0. I then set switch 2's priority to 0, and of course, root primary doesn't work on switch 1 this time either. So let's tune the STP topology by making switch 1 the root bridge for VLAN 10 and switch 2 the backup. I did so by configuring switch 1's priority as 0 and switch 2's as 4096. Before I show the STP topology, I recommend pausing the video to figure it out yourself. You should be comfortable with the process by now, but more practice is always good. Let's check. Switch 1, now the root bridge, has all designated ports. Here's switch 2, switch 3, and switch 4. So this is the current loop-free topology for VLAN 10. Pause the video if you want to take a look. And now, let's do the same for VLAN 20, this time making switch 2 the root and switch 1 the secondary root. I used the same priority values as for VLAN 10, 0 and 4096. Again, pause the video now if you want to figure out the topology. Let's check it out. Here's switch 1, not the root bridge this time. The root for VLAN 20 is switch 2 instead, with all designated ports. And here are switch 3 and switch 4. And the final loop-free topology. Once again, pause the video if you want to examine the topology. Let's move on to the second method of tuning the STP topology, modifying port cost. Port cost plays a role in both root port and designated port selection. A switch's port with the lowest root cost becomes its root port, and the port on the switch with the lowest root cost will become the designated port for the link. So, although it's usually sufficient to configure the root bridge and let STP automatically determine the topology, there might be a case where you want to modify a port's cost to further tune the topology. Port cost can be modified in two ways. One is modifying the interface's bandwidth with the bandwidth command. This affects the interface's automatic cost calculation, but is not the recommended method for modifying a port's cost. The better method is to explicitly configure the cost, which is much simpler. You can use the spanning tree cost command to modify the cost for all VLANs, or the spanning tree VLAN cost command to modify the cost for a specific VLAN. You can see both options here. Note that if you configure both, the VLAN-specific cost will take precedence. To demonstrate, I configured both commands on switch 1 G00. Spanning tree VLAN 10 cost 5, and spanning tree cost 50. Which do you think took precedence? The more specific command did. As shown here, G00's cost is 5. The result will be the same in other similar cases, not just for STP cost. A more specific configuration usually takes precedence over a less specific configuration. So here are the current topologies for VLANs 10 and 20. Let's use port cost to modify them. Here's the task. In VLAN 10, all traffic from users connected to switch 4 should pass through switch 2 before reaching the root bridge. And in VLAN 20, all traffic from users connected to switch 3 should pass through switch 1 before reaching the root bridge. Think about how you would achieve this by modifying STP port cost. In the next couple of slides, I'll show you how I did it. Let's look at VLAN 10 first. Currently, traffic from users connected to switch 4 will go straight to the root bridge via switch 4's root port, G01. How can we make G01 less desirable so that switch 4 makes G00 its root port? Remember the STP algorithm. If G00 has a lower root cost than G01, switch 4 should select it as the root port instead. Switch 4's root cost via G01 is 4, the cost of G01 only. Its root cost via G00 is 8, 4 for switch 4 G00 plus 4 for switch 2 G00. So I decided to increase G01's cost to 19, equivalent to a fast Ethernet port. And as intended, switch 4 changed its root port from G01 to G00. Now, traffic from switch 4 to switch 1 will pass through switch 2, as stated in the requirements below. So the task is complete for VLAN 10. Now let's do the same for VLAN 20. All traffic from users connected to switch 3 should pass through switch 1 before reaching the root bridge. I'll use the same method I did for VLAN 10. I'll increase the cost of switch 3's current root port, G01, to 19. That will make it select G00 as its new root port. Here's the command I used. Spanning tree VLAN 20 cost 19. And as you can see, G00 is now switch 3's root port. So, traffic from users connected to switch 3 will pass through switch 1 before reaching the root bridge. We have now satisfied both requirements. Now let's look at the final parameter, modifying port priority. Port priority plays a role in both root port and designated port selection. Here's the algorithm again. As with everything in STP, the lowest value is preferred. This is review, but like a switch's bridge ID, a port ID consists of two parts: a configurable priority, which can be from 0 to 240 with a default of 128, and a sequential number. For example, G00's port ID would be 128.1, G01's 128.2, then 128.3, 128.4, etc. With the default port priorities, just compare the names. G00 is lower than G01, so G00 is superior. Here's how to configure a port's priority. You can use the spanning tree port priority command to modify the priority in all VLANs, or you can specify the VLAN ID to affect only the specified VLAN. And just like we saw with the port cost configurations, if you configure both, the VLAN-specific configuration takes precedence. So here are the VLAN 10 and VLAN 20 topologies now. Let's tune them by modifying port priority. In both VLANs, frames forwarded between switch 1 and switch 2 should use the G01-G01 link. Do not modify the port cost. I recommend pausing the video to think about how you would do this. But now let's go through my solutions. Let's do it for VLAN 10 first. Currently, Traffic between switch 1 and switch 2 uses the G00G00 link, because G00 is switch 2's root port. So we want to influence the root port selection process. The instructions say not to modify the root cost, so we must modify the port priority. The question is, which port's priority should we modify? Here's the algorithm again. We want to affect this step of the decision-making process, the lowest neighbor port ID. So to influence switch 2's root port selection, we should modify switch 1's port priority, not switch 2's own port priority. There are two options to make switch 2 select G01 as its root port. We could make switch 1 G00 less preferable by increasing its priority value, or make switch 1 G01 more preferable by decreasing its priority value. In this case, I chose the former. I increased switch 1 G00's priority from the default of 128 with the spanning tree VLAN 10 port priority 240 command. Now, switch 1 G01 has a lower port ID than switch 1 G00. As a result, switch 2 made G01 its root port. So, frames forwarded between switch 1 and switch 2 will now use the G01G01 link, instead of the G00 link. Now let's do the same for VLAN 20. So we want to influence switch 1's root port selection. To do so, we should either make switch 2 G00 less preferable by increasing its priority, or make switch 2 G01 more preferable by decreasing its priority. This time, let's do the latter option. I made switch 2 G01 more preferable by decreasing its priority to 0, with spanning tree VLAN 20, port priority 0. As a result, switch 1 selected G01 as its root port, instead of G00. So, frames forwarded between switch 1 and switch 2 will use the G01 link now. We have satisfied the requirement in both VLANs. Here is the final STP topology for each VLAN, after tuning the bridge priority values, root costs, and port priority values. In most cases, it's enough to configure the root bridge and a secondary route, and then leave STP to figure out the rest. However, some networks have very specific requirements, and STP tuning like this might be necessary in some cases. Here's what we covered in this video. We looked at how to tune the STP topology by modifying bridge priority, port cost, and port priority. Now let's move on to a quiz to test your understanding. And make sure to watch until the end of the quiz for a bonus practice question from Boson Software's ExSim for ENCOR, the best practice exams for ENCOR. Here's quiz question 1. Examine the network below. Which of the following commands can be used to make switch 2 forward and receive frames on G01 instead of G00? Pause the video now to think about your answer. Okay, the answer is D, spanning tree VLAN 10, port priority 16, on switch 2 G01. This option is manipulating the final tiebreaker of the designated port selection process. Switch 2 G00 and G01, connected to the same segment, both have the same root cost. Switch 2 is the root bridge in this network, so their root cost is 0. And they are on the same switch, so the bridge ID is the same. Before issuing the command, G00 is selected as the designated port, because it has a lower port ID than G01. After making G01's port priority 16, G01 has the lower port ID, so it becomes designated. So switch 2 would forward and receive frames on G01 instead of G00, as stated in the question. Okay, let's go to question 2. Examine the network below. You issue the spanning tree VLAN 1 root primary command on switch 2. What is switch 2's bridge ID after issuing the command? Pause the video now to think about the answer. Okay, the answer is A, with priority 24577. Most likely, many of you selected B, thinking that because switch 1's priority is already 24577, This command will lower switch 2's priority to 4096 below that. However, that is not the case. Because switch 2's MAC address is lower than switch 1's, setting switch 2's priority to 24576 plus 1 for the VLAN ID is sufficient to make it the root bridge, even though switch 1 and switch 2's priority values are tied. Remember, the primary option for this command tells the switch to set the priority to 24576, or 4096 lower than the current root, if setting the priority to 24576 would not make this switch the root. Okay, let's go to question 3. Examine the network below. You issue the spanning tree cost 20 command on switch 2 G00. What is the effect on the STP topology? Pause the video now to think about the answer. Okay, the answer is D. The topology will remain the same. When the root bridge sends a BPDU, or a non-root switch forwards a BPDU out of a designated port, it doesn't add the cost of the designated port to its BPDUs. So even if we increase the cost of switch 2 G00 to 20, it still sends BPDUs with root cost 0. So switch 1's decision when selecting its root port is unaffected. Now, if we were to issue the command on switch 1 G00, that's a different story. That would affect switch 1's decision. It would select G01 instead of G00 because of G00's increased cost. Okay, that's all for the quiz. I hope this video was helpful. Now let's move on to a bonus question from Boson Software's ExSim for ENCOR. Okay, here's today's Boson ExSim practice question. You administer the two Catalyst 3850 switches shown above. Switch A is the root bridge. You issue the show spanning tree interface F02 command on switch B and receive the following output. So as you can see here, switch B F02 is the root port for both VLANs, 13 and 14. And there's more output here. Switch B F04 is an alternate port, or non-designated port, it doesn't say the STP version, for both VLANs. Which of the following should you do so that the link between F01 and F02 is the primary link for VLAN 14 traffic and the backup link for VLAN 13 traffic? Note that this backup here doesn't refer to the rapid STP backup port role. It just means a blocking port that is ready to take over if the root port fails. Before we look at the choices, let's think about that question. So we want this link between F01 and F02 to be the primary link for VLAN 14 traffic. Well, it already is. F02 is the root port for both VLANs. Then we want this link to be the backup link for VLAN 13. So how can we do that? Well, let's think of the root port selection process. First is root cost, and both ports have the same root cost. They're both directly connected to the root bridge. The first tiebreaker is neighbor bridge ID. Both ports are connected to the same neighbor, switch A, so that's a tie. The final tiebreaker is neighbor port ID, and that's what we are going to change to influence switch B's decision. Another option would be to modify port costs, but that's not one of the available choices. It's important to note that we have to change the port priority of switch A's ports, not switch B's own ports. To make switch B select F02 as the backup link for VLAN 13, we can either make switch A's F03 port more desirable by lowering its port priority, or we can make switch A's F01 port less desirable by raising its port priority. So let's look at those choices. First of all, I can immediately rule out A and B. Both of them involve configuring switch B's ports, but it's not switch B's own port priorities that influence its decisions. It's switch A's port priorities. Actually, I can rule out option D too, because it involves configuring VLAN 14. The F01, F02 link is already the primary link for VLAN 14, so we don't want to make any changes there. So the answer must be C, but let's double check. Issue the spanning tree VLAN 13 port priority 64 command on the F03 interface of switch A. So that lowers the priority value of switch A's F03 port, therefore making it more desirable. Then, switch B should select F04 as the root port for VLAN 13, instead of F02. Okay, so I'll go with C and click on Show Answer. And C is the correct answer. Here is Boson's explanation. I recommend pausing the video if you want to read through it. Okay, that was a quick look at Boson Software's ExSim for ENCOR. These are the best practice exams for ENCOR, and I highly recommend using them to prepare before the exam. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Jonathan Makara, Velva Jacob, Funny Dart, George, Nasir Chowdhury, Gustavo B.R., Marcel Lord, Pavel M., Dragos Hirnea, Zakib Shah, Mayor Salman, Vitaus194, Gina Lindley, Mark Jackson, Bold1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Maratuba, Roji Kuriakos, Arpad Konivez, 5 Feet, Owad Daniel Brown, Jose Alvarez, Hussein Yavuz, Kevin Hayes, Samuel Tavares, Roger Bratseth, Mustafa Ersoy, Nasser Zahar, Brian Grant, Georgi Gemejev, Kyle, Arlen Plagaria, Dear Diso, Adelson Pereira, Farad69, Joyce Njoroge, Lucien Stoichitoyu, Madmark 50484, Sean Powell, Alexander Stratan, Hiago Bicalho, Piotr Kaimov, Abdo Zizo, DMJ2, Kurt Nell, Abubakar Berry, Omid Farakesh, Steve Cox, Jasper Yim, Wilmer Romero, Enigma G, Laurent Lamb, Pedro Hartman, Ivano Capuano, Jefferson Steelflex, Alejandro Okana, Burl Campbell, Abhishek Sahu, Toxic, Sinan Sarisinar, Gio, Daniel Andrade, Jairo Francisco, Vijay Kumar Pili, Mike Crumby, Eliel Eliluli, Dragos George, Anas Hajjaj, and Sarmad S. Sorry if I pronounce your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.